You are incredibly brave, okay? You've come back for more. PMI. I'm proud of you. I know, it's not easy. You're probably still thinking, like, what the factor is this? Now I'm going to show you one more, and I think I can actually, enlighten you, okay? This is a really cool proof as well. So we all know that the formula is given to us that n1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus n cubed infinitely. It's all going to be this special formula that's going to calculate that for us, right? But now I'm going to prove to you that this is actually true using principle of mathematical induction. Again, first step, it's like you keep doing the same thing, right? First step is always to what? Verify, okay? Verify for n equals 1 and n equals 2, okay? In our class, we're going to do always 2 steps, okay? So verify that. How do you verify? Let n equal 1. That means 1 squared. 1 plus 1 squared over 4. It's going to equal 1. 2 squared over 4, which is going to be 4 over 4 is 1. And does that equal 1 cubed? Yes, that equals 1 cubed. So that's actually true. Let's try for n equals 2, okay? N equals 2, that means first 2 numbers. That means it's 1 plus 8. So it should equal 9. Let's try, okay? 2 squared, 2 plus 1 squared over 4, which is 4 times 9 over 4, which is 9. Because it's 36 over 4. And does 9 equal 1 cubed plus 2 cubed? Yes. So we know that this formula is good. Okay, so now we've done the first step already. Isn't this magic? Isn't this magic, guys? Okay, it's so cool. Now, second step. What's the second step? Yes, I know. This is the inductive step. We call this the inductive step. Okay, this is the inductive step. So we're going to do this. Always follow this, okay? Let k be any positive integer. Assume or let n equal k. Then, what does that mean, right? If you let n equal k, that means it's 1 cubed plus 2 cubed. But we should start with the series. Series, s sub k is equal to, right? S sub k. Because this is a series, a sum of cubes, right? Plus 3 cubed plus 4 cubed plus ... plus. Not n, but we're going to say k cubed is going to equal k squared, k plus 1 squared over 4. Okay? We're going to assume that this is true for every n equal k. Then, right? Then what is s sub k plus 1? Again, it's just adding one extra term. Right? ... plus k cubed. But we're going to add one more. What more? K plus 1 cubed. We're going to add just one more cube, okay, to this guy here, to the left-hand side. But here is a good place to stop because we know that we've proven this, but we don't know that it's true for k plus 1. So we're going to write our goal here. Let's write our goal. Our goal should be using our formula, right? So our goal should be k plus 1 squared, k plus 1 squared over 4. Because instead of n squared or k squared, we're going to put k plus 1 here and k plus 1 here. So our goal is this, k plus 1 squared, and this is k plus 1 plus 1. So it's k plus 2 squared over 4. This is our goal, that s sub k plus 1 is going to equal this. This is our goal. Okay, sorry about that, 4. Our goal is that if we add one more term to this sequence or this series, that we're going to get s sub k plus 1 is going to equal k plus 1 squared, k plus 2 squared over 4. And it's going to happen organically. Remember that, chicos? Okay? Now, let's take all this here. We're going to prove using this step, right? Wait, you know this. Isn't this just k squared? K plus 1 squared over 4? Yeah, that sum is this right here. Plus k plus 1 cubed. Okay? Yeah. So you're almost there. But this looks nothing like this. So you can't tell me that, oh, it's the same thing. You can't tell me that just yet. So let's keep going. Let's just keep doing the algebra. What I'm going to do is I'm going to try to combine them into the same fraction. So I get k squared, k plus 1 squared, plus 4, k plus 1 cubed, all over 4. So remember, we can separate them, right? This guy goes with this guy goes with this guy. So common denominator, okay? Okay, but this doesn't look anything like this. So I don't know yet that you've really proven it, okay? So I'm going to simplify this. How do I simplify this? What you can try doing is you're going, what can I factor out? Can I factor out something here? You're right. K plus 1 squared can be factored out. Then what are you left with? You're left with what? K squared plus 4k plus 1. Because I factored k plus 1 squared out, right? So I factored that out from here. I'm left with k squared. Here I took out k plus 1 squared, so I'm left with 1k plus 1, but I have a 4 outside. Okay? All over 4, of course. Don't forget the 4. Okay? Then, when I simplify this, I have k plus 1 squared. I know some of you guys are seeing it already. K squared plus 4k plus 1, right? Oh, k plus 4, I'm sorry. 4k plus, you have to multiply that and distribute it, right? And I get this, and all over 4. Don't forget that denominator. I have k plus 1 squared. This guy is simply k plus 2 squared. All over 4. Dun, 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 dun. It's the same thing. So S sub k plus 1, as we've proven here, is this sum here, this formula. And we know that this formula is true. But don't forget the third step. Okay? We have to conclude. So therefore, we conclude that the formula is valid for all positive integers n. Okay, we have to write that statement. Again, remember, first step is to verify that this formula works for n equals 1 and n equals 2. n equals 1, 2, meaning when you add up the first term. N equals 2, meaning when you add up the first two terms, does it equal this formula, right? Second step is the inductive step, where you let k equal any positive integer z, right? K equal any positive integer, and you let n equal k and assume that this is true. Then you show the inductive step, and then you have to make a conclusion. Okay? Now, if you're bold, try the third example. Now, if you think you're ready, try the homework, okay? More practice problems for you. But I'll have another example for you for inequalities. Ooh! See you later, alligators!